thank you. I think you all hear very well. Okay. Hi everybody. My name is Franziska Wilke. I'm coming from the GFZ in Potsdam. We are also part of the CRM-geothermal project, and we are very lucky because also GFZ had spent some money for our expeditions to East Africa. Therefore, I can also welcome here my colleagues here from Rwanda, Leon and Eugene, from Malawi, Gondwani, and from Tanzania, which is Albano Mahecho. They are all related to geothermal energy, often government institutes located in East Africa, in the different countries. So I think you got all the introduction already. So why we are doing this with the CRM project is that we want to harvest the geothermal energy and the heat, and meanwhile also get the CRMs out of the rocks. So why we are that is what we are doing here. So we have the brine, we have the reservoir rock, we have the water-rock interaction, the brine getting enriched in CRMs. Maybe we form scales. We don't want, maybe in the pipes, but sometimes we have that. And if we harvest the geothermal energy and we re-inject the brine, maybe there is a circulation system, in which we are reloading the brine again with CRMs, and then we can pump that out again. We have in our project 5 different geological settings. The last one in Turkey, metamorphic freeze, was now presented by Alba nicely. The saline water in sedimentary basins is a part of Simone Regensburg. And what I will present here is the alkaline systems in the East African Rift. So why East African Rift? So clearly the European Union is really interested also to have collaboration in East Africa, also to push a little bit the economy, our economy and the economy of Africa. So you have to see both sides. And the thing is, we have here in Germany the Kaiserstuhl, which is an alkaline system, but there is no such huge geothermal waters available. But in East Africa, as we will see in the next slide, the geology is very favorable. So what you see on the left-hand side is, in the east of Africa, you have on the red is Ethiopia. And there is where Africa opens like a zipper. Yeah? You can open from north to south, coming from the Ethiopia to Sudan. Now I have to leave. Coming to Kenya, to Tanzania, to Malawi. Technik. Genau, also Ethiopia, Kenya, Tanzania, Malawi. And then the rift system will split here at Lake Turkana, coming to the western branch of this East African rift. Uganda, Rwanda, and Burundi. So we have been very happy to get Moses Misongo. He's from Kenya, from Nairobi. He is a direct PhD student financed by the European Union, and with Dr. Lydio Laka, the supervisor. He already sent a paper or submitted a paper recently about the critical raw materials potential in Kenya. I have to say that Kenya is really much forward than we are in Germany because they have the geothermal energy utilized since the 80s of last century. This is actually a picture here of Tanzania. So we are in this side here. Actually, this is the Songwe or Rambo Fold or Mbaka Fold. So this fold has a lot of names, stretching from Lake Tanganyika to Lake Malawi. Genau. So that is how it looks like. So we start with Tanzania. We traveled from north to south. We sampled water, of course has some algae. We sampled gas, and we were lucky to also sample some drill cores, because the Tanzania Geothermal Development Company, so 100% daughter company of the government, has already drilled here at least 2 wells, what we know already. So that well is about 300 meters. At the surface, the water comes to 75 degrees Celsius. So that is really the surface temperature. So you can suggest what's coming in the deep. So it really economically of really a value, right? So it has a lot of pressure. So unfortunately, what we have not found, we thought really alkaline systems may have rare earth elements. In Tanzania, we haven't, so we have found them in 1.7 micrograms per kilogram and micrograms per kilograms also for yttrium, so that is a lot. Light rare earth elements, heavy rare earth elements, though there's no economic value. The highest concentration have been found for tungsten actually in the Natron spring. The Natron spring is above here, so Lake Natron stretches from Kenya into Tanzania. The thing is, Natron hot spring is nice and has also a lot of water. It's also in a natural reserve, yeah, and that is of course not very feasible for economic interest. So the rare earth element concentration is really limited, but there is potential for strontium actually, because here in this fold we have a lot of strontium, what we will see in the next slide. If you measure the gases and you are coming, there is a lot of nitrogen coming in your gas, then you will end up also having helium concentration of about 6 to 7 volume %. Yeah? And this gas domination here, this nitrogen domination, comes with the Tanzania craton, which lies just in the center of Tanzania itself. Already mentioned, there's a nice publication by Timo Kreitzmann. There's also a data publication already. And what was discussed here in this paper is that we have seen elevated concentration in certain places on the rare earth element, tungsten, scandium, and uranium. But it's more or less concentrated, or the elevation is concentrated in the lakes. And the lakes, of course, subject to evaporation. So that means that the springs itself do not have this enrichment in the rays, but the lakes have. But this is really evaporation system. So what was also said is Tanzania holds considerable geothermal potential. Also from alkaline hot springs, they maybe become extracted later with further technology improvements, probably at Lake Natron hot spring, but you have also to take into account the froggy ecosystem. So that might be important also if the company is coming to take action here. This is Tanzania. We are now going down to Malawi. We have sampled along this all these sites here. We found Malawi has the highest temperature in forms of geothermal waters with 78 degrees Celsius at the surface. The load in rare earth elements are even lower than in Tanzania. So also, I was not able to find lots of these rare earth element bearing minerals, and the gases are not that enriched in helium as we have seen in Tanzania. But we have done a little data publication, which is of course available to everybody. Now, so we have seen Tanzania, we have seen a little bit about Malawi. Now we are moving to the western branch of the East African Rift System, to Lake Kivu. Probably everybody knows maybe that Lake Kivu is rich in methane, so Rwanda is harvesting methane from the lake to produce energy actually, and so they're having the energy consumption done with the methane load of Lake Kivu and with water energy. So the geothermal energy could really be a next step or a next leg, let's say, to provide the energy for Rwanda and for the upcoming generations there. The water is also, again, quite hot, 70 degrees on the surface. There is a little bit of rare earth elements in Carrago, so that is a pot like this, actually. Yeah. So, but there is a steady flow of water coming from the subsurface. We have found some germanium also in the waters, which are can be localized to iron oxide, carbonates, and zircon. For helium, if you collect the gas, helium is also quite low here, unfortunately. To compare all these results, Tanzania, Malawi, Rwanda, so the temperatures for the geothermal waters is comparable, let's say. Also comparable are the low ratios for rare earth elements. Tanzania has the highest values in general, but also I have to say, so first, Tanzania waters or Malawi or Rwanda waters, we have here microgram per liters, not milligram, microgram per liters. So it's much lower than in Turkey, I have to say. Lithium, strontium is always on the left-hand side of the diagrams, rare earth elements and germanium on the right-hand side. And you can easily see that, so we end up here with about 10,000 micrograms per liter in case of strontium, let's say. That means if you have about, what I tried to calculate here is with lithium, if you assume 50 cubic meters of water to be pumped in an hour on 300 days with 100% extraction, of course that is just a dream, then you will end up having a lithium content of about 270 kilograms per year and strontium about 3 tons per year, which would mean about, with the price of today, of $20,000, which you can earn. The good story in East Africa is that the waters are really non-reactive, so that is alkaline waters, but they have the alkalinity is just due to potassium, sodium carbonates, and the real high temperatures which you can find all over the countries. To sum up this a little bit, so this is actually a quarry which is not longer vivid in the moment, so this is really strontium carbonates, and in this quarry you can find carbonates containing 2 to 4% of strontium oxide. The fresh precipitates from the fluids coming at this location is about 5-8% of strontium oxide. And in this diagram I just highlight, so we have with Tanzania the Rambo fold, both are at the Rambo folds, very high temperature and the largest content of lithium and strontium. And actually this is where Tanzania have drilled at least on two sites, in Gosi and in Nambaka. Yeah, I will finish. That is how it looks like. So you have at the place what I have shown, the outcrop. So you have the carbonates, normal calcium carbonates. You have the strontium calcite. This is the light one because strontium is more heavier than it looks in backscatter images. It's a little bit brighter. So that means the carbonates can dissolve, and you will have a reload in strontium if you pump back the geothermal waters once the strontium has been extracted and you repump the geothermal waters. Tanzania is a little bit also forward. Gosi, Mbaka, Songwe is all the same fold zone. This one is a little bit special, and I would not say that Tanzania will develop these areas anymore because it's gas deposits and that's a natural reserve. As I said, Lake Natron, it's a little bit tricky here, but they are already doing a lot of direct uses, and that I will show you. So here again, this is the area of interest, where the hottest fluids coming, with the hottest, where the largest concentration of strontium has been found. So that is how it looks like. So that is a normal bath and washing site. And of course, you dry fishes, you dry vegetables, you raise greenhouse. This for agricultural products, and later on it can be look like this. Yeah, so a little spar, but this is not the end of the story, I hope. Yeah, because East Africa has a lot of young people and needs the energy, and also this can be done easily with geothermal energy in this area. And of course, we did a lot of knowledge transfer. Thank you.